indicial equations. These are just equations where the unknown is the index. So, for example, in question 14a, we've got 2 to the power of x, and it equals 32. If I can rewrite the right-hand side here as 2 to the power of something, then I will be able to find what x equals. So, I know that 32 is 2 to the power of 5. So, if 2 to the x equals 2 to the power of 5, I can just look at this and say, well, then my indices must be equal. So, therefore, x equals 5. Looking at the next question, we've got 5 to the negative x, and again we've got a base of 5, so I want to write the right hand side with a base of 5. So I know that 125 is 5 to the power of 3. You may need to work that out. So if you know you've got a base over here, you might just start off to the side. You might go 5 times 5. Okay, that's 25, still not 125. Times it by 5 again. Okay, now I'm at 125, so you know that you're going to be using 5 to the power of 3. Okay, so back to the problem. If I know that that can be written with a base 5 here as 5 to the power of 3, so 5 to the negative x is going to equal that. Therefore, negative x equals 3, or we'll typically want answers in positive x, so x will equal negative 3. So there's our answer to B. When we look at questions like C, where we're given a fraction, we still want to go for the same idea. We still want to write our number in the same base that we've got over here. So again, 27, if I'm working that out, I know I want base 3, so I'll go, okay, well 3, oh hang on, let's put on a draw. So if I go 3 times 3, that gives me 9, so I'm not at 27, yes, times another 3, that gives me 27. So I'm going to use 3 to the power of 3 instead of my 27. So I can now write this as 1 over 3 cubed. And remember, as a fraction, we can write that with a negative indices. So we actually know 3 to the power of x equals 3 to the negative 3, using that negative indice to write a fraction. So now, looking here, we can just say straight away what x is going to equal. It's going to equal negative 3. In D, we have a little bit more going on. So I've got a whole number, and then I'm multiplying it by something in index notation. So what I want to do is get the index notation bit by itself. So if this is 2 times this, then I want to divide by that number in front. So let's go ahead and do that. So I'm going to divide by 2. Whatever I do to one side, I have to do the other. So they cancel out, and now I've got 3 to the power of x equals 2 into 16 goes 8, so 81. And then, because it's base 3, again, you'll work out what 81 is to base 3. So you'll start with your 3s. You've got 3 times 3 is 9, times another 3 is 27, times another 3 is 81. So we can write 3 to the power of x equals 3 to the power of 4. Therefore, x has to equal 4. So you can see going through that process of finding your power is very helpful. And the last question, they might throw an expression at you, and that's fine. We deal with it in exactly the same way. I look at my base, it's 2, I've got 16, I want to write this in base 2, so I'm going to do that now. 2, oh, hang on, draw. So I'll do 2 times 2, which is 4, times another 2, so that brings me up to 8, times another 2, that brings me up to 16. So 2 to the x minus 1 equals 2 to the power of 4. Because the bases are the same, I can now say that this index must equal this index. So x minus 1 must equal 4. And then it's just an algebra question. So I want to get x by itself, so I'm going to add 1 to both sides, and I get x equals 5. So that's worked example 14. And worked example 14 has questions in exercise 3C on page 104.5. And we're looking there at question 3 and 4. So you can get going on those questions. Good luck.